Hi, welcome to the second part of the series called Creating Instagram Filters with OpenCV. In this part, I'll show you how you can apply different color transformations on images, and we'll be utilizing lookup tables to do that. First, we'll see how to do this on images, create interesting filters that modify the red channel, green channel, and different color combination of channels and create very interesting effects on images. And then we'll see how to take this application and apply it on real-time video feeds. And when we apply it on real-time video feeds, we'll also use concepts learned from the previous post, where we learned to work with mouse events, where we learned to work with trackbar events, and how to create a full application where you can select filters with your mouse, click on it, and then change the intensity of each filters with a trackbar. So this will be a really exciting tutorial. So let's get started. So this is the Jupyter notebook that we'll be using for this tutorial. And it also comes with a blog post version that you can get from the link in the description below. So make sure to follow along using this video along with the blog post and the notebook. So that way you will get the best out of this lesson. So let's get started. So first we'll start by importing the required libraries. Remember, this is the second part. The first part we worked with mouse events and trackbars, and in this part we'll learn how to use lookup tables, LUTs. So this tutorial can be split into two parts. The part one is introduction to lookup tables, what they are, how to use it, how they are computationally efficient, and why you're gonna use this to manipulate the color channels. And then the second part we'll learn to apply different color filters on images and videos. To start off, we're going to import the required libraries, and we're going to be importing OpenCV, NumPy, and Matplotlib, the trio which is the most popular trio in image processing. Alright, so to start off, a brief introduction to what lookup tables are. So this image, I think, clearly highlights what sort of lookup tables are at a high level. So lookup tables are basically a table mapping of two different list Python arrays, right? So what happens generally is that you create a mapping list. So this is sort of what it looks like. So consider this. You wanted to create a Python function which transformed each pixel, which takes each pixel and takes a square out of it. And then it replaces that pixel value with its squared value. So if you take 2, you square 2, you get 4. So you take 4, you get squared 4, you get 16, right? So if you created a function which takes an image and checks each pixel and squares it and then replaces that squared value with the original value. So if you do this without lookup tables, it will be computationally very expensive. But if you replace this whole snippet with lookup tables, so you only have to do the computationally expensive part once and store the values in a table, and then just look them up every time you're going to transform any new images. So that is why it's called lookup table. You do computation once, you store the values in a table or a Python array, and then each time you want to do a transformation, you look them up from a saved table. So this is why these are really great when you're working with this sort of stuff. So let me just show it to you how in action. So this is where I'm doing this manually. I created a table, a square table, an empty array Python, and then for I in range 100, so I iterated over 100 times, and I manually squared every element, and then converted it into an NumPy array. And then this is how it went. So when I did this manually, I get 0, 1, 4, 9, 16, 36, 49, 64, 81. So this is what I get. And then what I'm gonna do is that I'm gonna put an input variable and use lookup table to get the value out of it. So I'm not using lookup tables right now, but this is the general idea. So the square of 10 is 100, right? So every time if I want to get a square out of any new value, for example 6, I'll just put input 6 and get the square table out. So this is the index. So index 0, 1 to where exactly in the list. So this list is a mapping of squared integers from 0 to 100, right? And then after the mapping is done, I have a stored a table which I can look up later on for any value out of 0 to 100. So if I do this like 98, what's the square of that, I can get this value. I'm not doing anything, I'm not doing any computation here, so this will be really fast compared to like actually doing something like this. So that it's way faster this way. So and this is really great when you're working with images. So when working with images, you have images with very high resolution, right? You may have a data set of thousands of images, and each image may have a really high resolution. So if you're looking to transform all the images and do color transformations, lookup tables are the way to go. Otherwise, the whole thing will be really computationally expensive. So, and there's also another advantage of like lookup tables that we'll learn later on. It helps a lot in doing various transformations. So, anyways, by the way, if I do like 102, it will give me an error because this index is out of range. I didn't store values from 0 to 102. I did just 100. If I wanted to expand this range, I can do this, and this way it will like just work fine. I think I might need to do 3 because it's 0 indexed, right? So yeah, so this is how this whole thing works. So let's just replace those values back so that you get nice work at the end. So anyways, there's that. And so this is the intuition of the whole lookup table. You create a mapping, and then you at the later stage you just put up indexes and get the mapped value back instead of doing the computation, right? So an example of using lookup tables in action would be transforming a simple like image like that which has a white background, which has a black person with a white background, and then like just swap it out, change black to white and white to black. Now you can do this with thresholding, but with lookup tables, once you have done the mapping, this is like much faster. And obviously this is just a very basic example, and you can do lots of different transformations besides raw thresholding. So just to explain and show you the lookup tables function, this function in action, I'm just going to demonstrate how you can convert an image with a white background to black or vice versa. So so to do that, what you will do, first you will create a lookup table. So for that you will use this function cv2.lut, and you will pass in two things here. You will pass in the source image, and you will pass in the lookup table. Now this function actually maps the image using a lookup table. It does not create a lookup table. For that you can just do something like this. So to create a lookup table is just creating a Python list of mappings. So for working with images, obviously you will have a list with a range from 0 to 256, because like a pixel can take up values from 0 to 256. So that is the maximum range. So that is how you will go. So for I in range 256, so we'll iterate a loop 256 times, and here's what this code does. It increments all the values that are above 220. We're gonna like make them black. So we're gonna append 0 for all those high values, and all the values that are like less than 220, we're gonna retain the original values for that. So we're gonna retain the original values in those cases. Other than that, we're gonna like transform it to 0. So all the values that are above 220 are gonna become 0. Values less than 220 will retain its original values. We can do some sort of similar stuff with using thresholding, various thresholding techniques. But again, the intention right now is to explain it to you how to do this with lookup tables in a most basic way. Then we'll look at some advanced. When we're working with multi-channel images, with color images, this will be like you'll see the power of this in action. So anyways, just run this and let's see the transformation. So this was the sample image, right? And this was the whitish background which I needed to replace. And remember, I didn't want to replace these values, so these were retained, right? These values were retained, these values here. So I only wanted to transform the values that were above a certain white threshold. So that threshold I set it to 220, and this way only this part was modified to black. And again, just to recap what's happening here, I'm reading an image, I'm creating an empty Python array, I'm iterating over 256 times. If I is greater than 220, I'm appending just a 0 to this empty list and 1 to list if that is not the case. So what will end up happening is that I'll see a list of values which are zeros up till 220, and then later on it will be ones. So it will be a mix depending upon each pixel values. So this will be a list of zeros and ones. So if I just showed you the list values, so this is how this will look like. If I so this will be all zero up till 220. We'll retain the original values. Above 220, it will be all become black. So this is how this whole mapping looks like. So this is actually a lookup table, white to black table. This is called a lookup table, which we have just created. Now to do the actual mapping, we'll call the lookup table function cv2.lut. Now in this function, we'll pass in the image which we want to be transformed, and then we'll pass in the lookup table in a NumPy array format. So unsigned date format. So this is how we'll pass this, and then we'll get the final transformed images using lookup tables, and this is the output image that we get here. So this is the whole thing in action, and this was for a black and white image. Now let me show you another transformation which is very similar to the above one, but it is sort of a reverse one, because this time I'm gonna transform this blackish area to pure white like this. So here what I'm gonna do is that again I'm gonna do the same thing, create an image, create a black lookup table called, this time I'm gonna call this one black to white table, and I'm gonna iterate over this loop 256 times, because we need to do that 256 pixel values range of each pixel in an image, and then at any point that pixel is less than 50, the intensity of that pixel is less than 50, I'm gonna turn it to white 255, and if that is not the case, I'm gonna convert it to I'm gonna retain its original value. So that is what happens here. So the pixels that have intensity less than 50 are most likely blackish, and so that's why I'm converting all this black to white. If I wanted to make it somewhat gray, I could have done something like, I think that 195, something like grayish. So that way I map all the black values into somewhat a gray tone. If I was working with a 3-channel color image, I could also have done replace this black area to maybe a different color altogether if I was working with color channel images. And in the same way, in a similar fashion, you can also get rid of green screens. So have you seen high resolution images where videos where we have a green screen and the person is acting, and then later on in the production stage you remove the green screen? So you do some sort of similar thing. You can replace the whole green color with something, with a different thing, using lookup tables and something like that. So really cool. And yeah, let's place this and run this again. So yeah, all right. So now what I'm going to do is that, now that I've explained the intuition of the lookup tables and I've explained how to work with lookup tables, now I'm going to show it to you the computational gains that you get with lookup tables rather than using raw Python code. So here's what I'm going to do. I am going to create some random 100 images of resolution 960 by 1280. And these are just going to be empty images of which I'm going to create using np.zeros, and so these are just going to be black images which I'm going to manually change all the pixels in this image that are less than 50 to 255. So this is a transformation that I'm going to make just in Python without using lookup tables. So without using lookup tables, what I get, I'm going to just run this again. So I'm getting an average of around 200 milliseconds. So this is what I'm getting. To around 200 milliseconds is the time it takes to do this in raw Python, right? Without using lookup tables. So to transform all the 100 images and convert all the pixels with values less than 50 to 255, this is what the total time it took me. So if I had used lookup tables to do the same thing, let's see the time it takes. So first of all, obviously I'll need to create a lookup table. So a lookup table that converts all the pixel values less than 50 to 255 otherwise it retains those values. So this is the code for that. Pretty simple. So let's run this. And now this only has to be done once. So once we have created a lookup table, now it's time to use the lookup table and transform all the 100 images. And let's see the total time it takes. So as you can see, it's pretty fast. 194 ms for this and like 81.2 milliseconds, for this. So it's more than twice as fast to use lookup tables instead of just using this. And you can imagine if you had, instead of 100, you had a lot more images and you have a more, high resolution. Now this can be the difference between, transforming a data set of millions of images or thousands of images, and it can mean a difference between hours of work, if not days. So it's worth it. It's definitely worth it, to use lookup tables and learn how they work instead of transforming. So again, very, very useful when working with large data sets, and also useful when you're working with real-time images, when a stream of video is coming and you want to transform each and every single image very fast. So very useful then. All right. So now what I'm going to do next is I'm going to show you how to use lookup tables to apply different color filters on images and videos. So really cool. So for that to happen, first we'll create a lookup table that increases the intensity of each channel that you pass it to. So for example, if I pass in a red channel, it will increase the reddishness of that image, and it will intensify it. So for that, what I'm going to do is get rid of all the lower pixel values and transform all the values to higher pixel range. So this is what's happening here. I'm creating a lookup table, a color table. And remember, whenever you're working with images, the lookup table or the Python array that you're going to map is always has to be 256. The length has to be 256 because you need to have a mapping for each and every pixel value, and the total values that any pixel can take in an RGB space is 256. So once I run this, and I'm going to just show it to you how this looks like. So what I'm doing here is that I'm just creating a color table or a lookup table where I'm pasting the values from 128 to 256 twice. So this is what array.extend does. So what you're doing is that you're just pasting two values twice. So as you can see, if I print out the first 10 values, it is 128, 128, again 129, 129, 130, 130. So because I have to make it 256, I could have just repeated this loop twice. That could have also worked, or I could just do extend something like that, and it works fine. So this way I have an array or a table mapping of length 256, and in this array what I have is 128, 120, each value from 128 to 256 repeated twice. Now if I map each pixel to this sort of a range, what will end up happening is that all the lower value pixel, for example, if I have an image which has a red channel and some pixels are in the range less than 128, like they have range like 50, 60, 70, whatever the values, they will be transformed to higher range value above 128. So this is what's going to happen, and for that I'm going to create a function called apply color filter. This function will take an image, channel indexes, and it will transform all the the image that you pass it to using the color table above. So, and then it will display the results in Matplotlib. Otherwise, it can also return it if you're working with videos. If you're working with Matplotlib, it will just show the results. And this is where the transformation is happening. So we have an output image, and I'm using the lookup table function, passing it the the image, and passing it the array which we created above the color table, and it's doing the mapping. One other thing that's happening here is that I'm also passing it the channel indexes. So remember I told you that if I was giving you an example of enhancing red channel. So it can be any channel, it can be green channel, it can be blue channel, or it can be a combination of these channels. So this will be a Python array of probably of length 3. You can of any arbitrary length, in fact. So what will end up happening is that we'll loop over each of the index, and if it is, for example, if you pass in an index arrange something like this. Let me just show like what I mean. If you set channels, okay, if you set channel indexes to something like this, if you do something like this, now what this will do is this will only change the green channel and the red channel. If I do this, this will only change the blue channel. I'm considering that we are working with BGR images, blue, green and red, right? So 0 is blue, green is 1 and red is 2. So if I just want to work with or modify the blue channel, I'll just do this. If I want to modify the blue channel and red channel, I'll do this 0 and 2. So what it will do, it will loop through each of the elements in this array, and for each channel index it will modify that and use lookup tables to map it to a higher range value. So again, you can modify any singular channel or a combination of channel or all three channels if you want. So this way you'll end up creating various effects on every single image. So let's run this and let's see it in action. I'm just gonna get rid of this line. Okay. So I'm gonna see it in action on a couple of images. So this time what I'm doing here is, as you can guess, I'm changing the blue channel 0. So if I enhance the blue channel of this image to a higher value, this is what this looks like. So if I do similarly, like to if I modify a different channel, like if I do green channel, enhance the green channel of this image, this is what this looks like. If I enhance the red channel, this is what this looks like. So this, this looks gives a warmth effect to this. Now these are all individual manipulations, right? Blue channel manipulation, green, and then red. What about combinations of these channels? So this is what I'm doing here. Here I'm modifying the blue channel and the green channel, and this is what this looks like. We get a cyan effect, right? A cyan color. Then if I do this blue channel and the red channel, you get this purplish effect. So very interesting. Now this is all cool and all, but what if you don't want to modify or transform the image in a linear fashion, in a static way, because we have no control how much purple we want. Of course we can change the color channels here, the transformation here, and it will ultimately affect that. But what if we want to have the control over how much how much intensity we want to change for each color channel? If you want refined control over this sort of a thing, and we also wanted, what if we also wanted to transform each image in a non-linear fashion, so that we don't see this looks like a rough transformation, right? All the image becomes purplish. What if we wanted to do some sort of a transformation that does it in a non-linear fashion? So for that to happen, you can use gamma correction. Now gamma correction is a non-linear technique to change the brightness of an image. You can make it darker or you can make it brighter, but it does it in a non-linear fashion so that it looks more smooth and a lot nicer. So this is the formula for that. This is the O is for the output image, I is for each pixel in the image, and then we have 255. And then Y is this a gamma power value, and then 255, we multiplied the whole thing by 255. So this is the whole formula for gamma correction. So here's what I'm gonna do. I'm gonna again create another lookup table and call this one intensity table. And for each value in this table, so I'm going to iterate over 0 to 256. I'm going to apply the gamma correction formula on it. So gamma correction formula on it. Obviously, I'm going to clip all the values that they don't get below 0 and above 255, because this is the range that the pixel values have. So they can't go over this value, and we can we'll have values from 0 to 255, just like a pixel value can have the values. So once we're done running this, we'll have a list, a lookup table of every value transformed, using gamma correction. So and by the way, the value of the gamma correction that we use for this particular transformation, this y variable, was set to 1.0. And later on we're going to see how we can change this value, because depending upon this value, you'll be able to see different sort of effects with the intensity change. And this gamma value will be equated to the scale factor. So whenever I'm going to create this function, again change intensity, which is going to take an image, which is going to change channel indexes, and these all, the same thing is going to happen, like the way we work with this this function, the apply color filter function. But the only difference here is we have another variable called the scale factor, and this scale factor is a variable which you can see from this formula, this gamma value. So this gamma y value is going to be the scale factor. If I set this scale factor as 1, then nothing is going to be changed. This same lookup table is going to be used, but if I use a different scale factor value, then I'll have to create another lookup table for that specific value and then use that to do the transformations on the image. So this will give you the flexibility of testing out different intensity values or the gamma values on different images and see the effects in action. So anyways, the code for that is this. So this is the code, and so here what we have is that we have a gamma value. If suppose I didn't do any thing differently, if I just set the scale factor as 1, then this gamma, like you can just the whole thing, like you don't have to run this. So it will ignore this, and we'll use the previous gamma value, and we'll just transform the lookup, like the whole image using the previous this intensity table lookup table. So everything is same. If the gamma correction value is not changed, the whole code becomes pretty much the same as this one. If you don't change the gamma correction value or the scale factor value, right? This is not executed, and we do the same thing, just using a different lookup table which we created above this one, intensity table. We're using that to transform the whole image and the specific channel indexes, and then we're displaying the results with matplotlib. I just adjusted the notebook size. I forgot to do that initially. So alright, so that's done. So now all the code is a lot bigger. So let's continue on. So now that I've created this change intensity function, let's see it in action. So I'm going to apply it on this image, and we're going to see the results. So this is the color filtered image with just applying a normal filter. So if I do apply color filter function and see the results, this is what I get. But if I like adjust the filter with a scale factor of 0.6 using gamma correction, this is the result I get. So as you can see, you get much more refined results by adjusting the intensity of how much you wanna like change or transform each individual channel. I can also like just check this out with a different scale factor. So 0.2 will give me something like this. So I can work with this and create very interesting effects, and like this is the flexibility that you get when you use gamma correction and create this sort of a setup. So here's what's happening. If I like use a scale factor other than 1, what will end up happening is that it will compute a new gamma value, and once that happens, we'll create a lookup table, a new lookup table for that particular gamma value. If you're not gonna change the gamma value, and once you do that, you will not create another lookup table every time you run this code. So if I just stick to 0.6, a scale factor of 0.6, and I don't change that, then I won't be creating a lookup table each time I run this code, right? It will only be done once you use a different scale factor, which will end up computing a different gamma value. So for that, yeah. And by the way, if you have a large data set and you have already decided upon different values of scale factors that you're going to use, then you can create multiple lookup tables for each scale factor, and this way you don't even have to create new lookup tables for each different scale factor value. So that's one way to make this run more efficiently. So let's check it out on another image. So this is where when you increase the red channel intensity 3 times by like doing something like this. So pretty interesting effects that you can manipulate at a very good level. Alright, so that is all when you're working with images. Now let's move on to the real-time webcam feeds, and this is where we see the fruits of our work of this blog post and the previous blog post combined in action. Now what we'll do is I'm going to create a callback function, as you can already tell by just looking at these variables. So these are the variables that OpenCV passes to the mouse callback function: event, XY coordinates, and flags and user data, which we don't normally use. So we're going to just work with this. So whenever user presses the left button, down button, we're going to first check which particular filter the person is selecting. So just as a recap, I'm just going to first show you what this looks like so that you don't get confused here. So this is the final application in action, right? So what we have here is different color palettes. So we have like, I think 6 color palettes. This is the normal one. And if I click on any of them, press the mouse down button, that color effects is being applied on the whole screen in real time. And then what I have, secondly, I have this track bar. Now this track bar adjusts the intensity of each individual color channel. So I can make it a lot, so I can, adjust the whole intensity. So this is adjusting the scale factor and then ultimately adjusting the gamma correction value. And so pretty cool, exciting, like Instagram-like effects you're gonna see when working with these filters and adjusting the intensity values. So I'm just going to close this up, and now we're going to see the code that makes this possible. And the code is pretty simple if you have understood what I've just explained in this tutorial, and you've also understood the previous mouse and trackbar usages. So it's almost a repetition of that. So what's just happening here is I'm just checking to make sure if the left button is clicked, and if it is, I'm checking in which area it has been clicked. So I have specified multiple areas. So if, as you can see, there are 6 to 7 color palettes, and each color palette holds a particular ROI inside the whole image. So if I clicked my mouse inside that particular ROI, I'm gonna select the filter will be blue, because that is where the blue filter will be present, which is that is the area that I am reserving for the blue color. Similarly, different areas are being reserved for different colors. So this is for green, this is for red, this is for normal, this is cyan, and this is purple, this is yellow. And each time I'm setting this variable filter applied to this particular color name, I'm also specifying which channel indexes that we need to manipulate. For red green channel, I'm gonna manipulate this channel index. For red channel, this is gonna be the one. For cyan, these two channels should be manipulated. For purple, you need to manipulate the blue channel and you need to manipulate the red channel. So for yellow, this is the combination of channel indexes that you need to manipulate. So what's happening is that this function checks where I'm clicking and then sets the required variable in that particular manner. So this is all that this function is doing, checking where I'm clicking and then setting the required variables. That's it. Now the next function, what it does, it takes these variables and then applies that function and calls the required methods that applies the filters. So what I'm going to do first is I'm going to initialize the camera, and then I'm going to create the name window. I'm going to create the track bar and attach it to this window which I just created above called color filters, and I'm also going to call the mouse callback function and attach it to this window. If you don't understand how to work with track bars and mouse callbacks, I would highly urge you to watch the previous tutorial that came out, which explains how to work with these things. So what I'm going to do next is that I'm going to set the filter apply to normal. So initially the filter will be none, so it will be normal. So now what I'm going to do is next is specify an empty array of our channel indexes, and then I'm going to start reading frame by frame, and then this is what I do, literally flip the frame so I see a mirror image of myself, and then I have a dictionary like this. So this dictionary holds the key for the key values of inside this dictionary are the names of each filters, and the value is the method and the configuration for the variables inside this method. So for example, if I clicked with my mouse on an area which triggered the green filter, right? So the variable will be green, and if I want to display the greenish effect, I need to call the apply color filter method, and I need to set the channel indexes as 1. So this is the function I need to call, and this is the channel indexes I need to pass. So for that reason, what I'm doing is I'm just for ease of use, I'm just creating a dictionary. I can also do that by just creating multiple if and else conditions, but a more efficient technique would be to just create a dictionary where you have keys that hold the variable names and the values that the functions that you need to call for that required filters. So that is a much more efficient way. Again, you can do this with if and else conditions if that is more intuitive for you, but that would be a bit slower, I think. Anyways, once you create this filters dictionary, what I'm going to do next is that I'm gonna so just ignore this part for now. I'm going to explain this. This is just a simple thing. I'm going to explain it in a bit. So the next thing I'm gonna do is that I'm gonna use this variable filter applied. Remember, this is the variable that we get from here. So anytime you click anywhere, filter applied variable is updated for that particular area. So you clicked on the red area, the filter applied will be red. And if the filter applied is red, then when you pass, where is it? Where is it? Where is it? Where is it? Okay, I lost it. So that's what happened when you have, yeah, I think it was sort of like here. Yeah, so when you pass red inside this dictionary as a key, obviously then this would be triggered, right? This function will be called apply color filter, and this frame will be passed, the channel indexes will be set to 2. So this particular configuration will be triggered, and then you'll get the updated frame. Now this frame will be reddish. Now this part is done. Now this whole thing that we have just discussed right now is the whole logic for selecting individual filters and applying it on the screen. Now comes the second part where we adjust the intensity, and for that to happen we'll be using another function called change intensity. So this is the another function which we created above, and I showed to you how it worked on images. So this is the function that we'll be calling, and for that to happen first we need the filter intensity, right? And this is going to be given to us by the track bar. So we have a track bar that on top of the image where a user can adjust, and anytime the position of the track bar changes, we can get the updated filter intensity value here. So this is the value that will be updated. You can get the updated value by running this get track bar position, telling which track bar you're talking about, telling the name of the window, and then obviously we're just normalizing the value so that we get the value in the range that we need to adjust. So we get the filter intensity value in a normalized manner, and then we use that value to change the intensity of the whole frame after the filter is applied. So both of them are accomplishing different things, and you can use them independently. So you don't need filter selection for the intensity and vice versa. You don't need intensity function and to apply intensity to see the filter effects in action. Both of them are different things and accomplishes different effects, and you can see them both in action when you run this both of them. Anyways, so once that is done, this whole part is just changing the intensity. What we're going to do next is, yeah, so this is the part where we're just annotating the and drawing rectangles on the the video feed. So if I run this, now you're seeing this, like these small windows are being created by this sort of a function here. So here we are creating these small windows. So this is the whole part for that. This is again just for visual purposes, where you see the whole frame being applied, copied and then being applied as small windows on each of these areas. And similarly, this whole code is responsible for just making sure that whenever you click on each filter, it gets a green border around it, and the rest of the borders remain white. So if I click here, this becomes green. A green border appears here, right? And the rest of them are white. Similarly, if I selected a different filter like this one, all the remaining ones are white, and this becomes this has green borders. The logic for that is simply this. So depending upon which filter is selected, you change the border of that green, change the rest of the borders and make it white. So that is the logic for that here. So that is all. And again, these are just for visual purposes. You can do a lot more to get make it more nicer, make it more cleaner. and you can even use a library called Pygame to have more appealing and sliders and more appealing selectors. So again, this is just our programming logic and image processing code that accomplishes creating interesting visual filters, right? And for the GUI part, you can make it look a lot nicer than what I've just done so far using just OpenCV, because the intention was to create this using just OpenCV. If you use external libraries like Pygame and GUI libraries, you can take this and to a whole new level and create a very nice looking GUI application that applies filters and visualizes them in a very nice way. So a lot can be done on this. So anyways, that is all for this lesson, and in the next one we're going to see some more interesting filters, and finally we're going to see the whole Instagram app in action, because right now we're just working with LUTs and manipulating filters at some level, but in the next one we're going to see more advanced filters and more mathematical transformations that are going to take this whole like to the next level. So I'll see you there, and bye.